2011 JMC question number 25. The diagram shows a trapezium made from three equilateral triangles. Three copies of this trapezium are placed together without gaps or overlaps, so that only complete edges coincide to form a polygon with sides n. Okay. And the question is, how many different values of n are possible? So actually, guys, as for this trapezium, how many sides do we have? We got 1, 2, 3, 4 sides, right? And if you put two of that together, you will have 4 plus 4, that will be 8 sides. But actually, if you put them together, two of sides will combine together, so you have to take away 2 at least, right? So that means if you put two of them together, at most we're gonna have 6 sides, right? 6 sides. But here you got 3 copies of that. That means if you put 3 of this trapezium together, that will be a 4 plus 4 plus 4. Each of them gonna have 4 sides. And if you combine 2 of that, at least you have to take away 2 sides, because that cannot be the outside length, right? And then also you have to take away 2 more, because you got 3, 2 of that will take away 2, and another 2 of that will be take away 2 sides. So let's see, what do we have? That means 4 plus 4 plus 4, you got 12. 12 minus 4, you got 8. So that means at most, if you put that 3 of these copies together, you're gonna have 8 sides. At most, you're gonna have 8. Okay, and let's see. Now the question convert into: is that possible to get 8 sides? So the n, is that possible equals to 8, or is that possible equals to 7, 6, 5, 4, 3? Right? You just check: is that possible to get all of these different types? Let's see, as for this 8 one, we can get that by, you see, put this trapezium here. Okay, let me find some place to do that. So we can have this regular hexagon first, which is gonna look like this. Okay, this is a regular hexagon, and that one we got 6 sides. And of course, you can put that one of the trapezium at the top, in this direction, in the backward direction, right? And guys, if you count it, you got 8 sides. So 1, 2, 3, 4, 5, 6, 7, and 8. So that means for 8, we can get that, right? And how about the 7? Actually, as for the 7 one, you can have that regular hexagon as well, but you put the 3rd one in some other direction. And for this, you have to try it by yourself. Okay, you can have this. And this time, we don't put that one more, the last trapezium on the top. We just put that here. Because if we put that this way, you can have one less side, because these 2 sides will be only one of that. And this will be a 7 sides polygon. So let me count that: 1, 2, 3, 4, 5, 6, and 7. And that means for 7, we can still get that, right? And how about 6? Actually, if you want to get a 6 side, you cannot use that regular hexagon, because no matter how you put the last one, it must be more than 6. So basically, let's put 2 of that in a line first. Because this way, we'll have this parallelogram, and that is just the 4 sides, right? That's just 4 sides. And we just put one more there, and we can put that here at this place. Okay? And now you count it, you'll find it's 6 sides. Let's see. 1, 2, 3, 4, 5, and 6. Okay, this how we got this 6 side polygon. So 6 1, you can also get that. And as for the 5th one, actually you can get that by, you see here, as for the 3rd one, that is the 6th side. And for the very left one, you can put it here so that you have less sides of a polygon. And let's see how do we get that. The 4th one, which is, let's try to get this first. Okay, this is what we have. And let's make this a little bit longer. And here you got it. And actually you can put that one at this place. I have to draw that nicely. Yep, like this. And then let's put one more here. Okay. And now you just count it. So that'll be 1, 2, 3, 4, and 5. So that means 5, we can also get that. And then how we get the 4th side, that is the easiest one, guys. You just put that in a line. You put all of the 3 in a line, you will get it. The 5th one. First 2, let's put that like this. This is 1. This is 2nd one. And this will be the 3rd one. If you put them in this way, you'll see that's just a trapezium, which is a long trapezium. And that is 4 sides polygon. 1, 2, 3, and 4. So 4, we can still get that. But actually, guys, the last one is much harder to get. Let's see. Last one, that'll be the 6th one, right? As for this one, guys, you will see that you got this 120 degrees, which is one of the vertices, one of the angle of the trapezium. So you know that if we put 3 of such angles together, is that possible we get a triangle? Let's see. This is the first one. Just put it here. Then as for the second one, you should put it at this place. Just extend that one a little bit longer and extend this one a little bit longer and connect that. Okay, so this will be one of the trapezium you have. And then this, the last one, should go to this place. That should be here. Let me connect that and connect it. Okay, so you see, you just put 3 of that together. 1, and let me change my color. And 2, right, the pink one, and 3rd one, right. Okay, that's how you get a triangle. Now we can answer the question. It said how many different values of n are possible? That would be 8, 7, 6, 5, 4, and 3. So there'll be 6 of that are possible. So we choose C as the answer.